So in question 3 of the free response says, bottled milk is taken out of the refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk where m of t is measured in degrees Celsius, and t is the number of minutes since the bottle was placed in the pan. M satisfies this differential equation here. Now at time 0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Now they give us two important things that may be very important. It says the increasing function. They tell us that it's increasing. They also say that m of t is less than 40 for all values of t. Now those two pieces of information could be very important for us. Now part A says they give us the slope field, and we want to sketch the solution curve through the point 0, 5. And they give us this right here. So all we have to do is go with the flow. And what ends up happening is that it should level off. It should never cross this line. And as we go, our slope should be decreasing and approaching 0 more and more. And that's all we had to do for part A. For part B, it says, use the line tangent to the graph of m at t equals 0 to approximate m equals 2. Now we are still using this right here, that m of 0 equals 5. But what we need is the slope in order to get our tangent line. So that means we're plugging in t equals 0, but we're also plugging in m equals 5. Now there's no place for t, but there is a place for m. So you have 1/4 times 35, and that's 35 over 4. And there is our slope for our tangent line. So when we write our slope, so we write our tangent line, it's going to be y minus 5 equals 35 over 4. Now for some people, you don't need the minus 0 part, just need the t. That'll work just fine. Now that's only part of it because we want to approximate m of 2. So that means we're going to plug 2 in for t and see what we get for the slope. So I guess if I'm being fair, I probably should write m right here instead of y, but I don't think the graders are going to be that particular, but we'll see. So we have m minus 5 equals 35 over 4 times 2. So that means m equals 5 plus 35 over 2, so that's 10 over 2, 35 over 2, so we get 45 over 2. And since this corresponds, we're going to put degrees Celsius because this corresponds with a temperature. So that is part B. Now part C says, write an expression for the second derivative, d2m over dt squared. So we're going to take this differential equation and we're going to find the second derivative. So d2m over dt squared equals 1/4 times, now this is a multiplication coefficient, so it hangs on for the ride. 40 disappears, and then we get negative dm over dt. So we're going to have to make that replacement. I'm going to bring the negative out front. So we have 1/4 times 40 minus m. Negative 1 over 16 times 40 minus m. Now we want to use this to decide whether the approximation from part B is an underestimate or an overestimate. Now, I want to recall one important thing that we pointed out. It can be shown that m of t is less than 40. Now, why is that important? Well, that means since m of t is less than 40, that means that 40 minus m is always going to be greater than 0. And so that means negative 1 over 16 times 40 minus m is going to be less than 0. So that means the second derivative is going to be less than 0. And because the second derivative is less than 0, that means that m of t is concave down. And if you look at our solution curve back in part A, that kind of makes sense. Here it's the slope is always decreasing. So back down to here, since it's concave down, that means that the approximation, the 45 over 2 approximation, is an overestimate. Because when something is concave down, the tangent line is always going to be above it, and the curve will be below it. And so since this is on the tangent line, this is too high. And then part D, use separation of variables to find an expression for m of t, the particular solution, given m of 0 equals 5. So when we separate, we have 1 over 40 minus m dm equals 1/4 dt. So now we've had our separation. So now when we take the indefinite integral, we get negative ln of 40 minus m equals 1/4 t plus c. Now this is as good a time as any is to find what c is equal to using our constants, our points 0 and 5 for m and for t. So negative ln 40 minus 5 is 1/4 times 0 plus c. So our value for c is negative ln of 35. So now that I put that in, now I can continue solving to get m by itself. So first I'm going to drop the negative. So we have negative 1/4 t plus ln 35. So we're going to use e to cancel out the ln. So we have 40 minus m equals e, negative 1/4 t plus ln 35. Now let's remember our rules for exponents. We can break this up, e to the negative 1/4 t times e to the ln of 35, and the e and the ln will cancel. So I'm going to take all this back up here. So we have 40 minus m equals negative 1/4 equals, sorry about that, 35 e to the negative 1/4 t. Come on. There we go. So now this term goes over here, and m will go over there. So 40 minus 35 e to the negative 1/4 t equals m of t. And there is our particular solution. Thanks for watching, and we'll see you in the next problem.